All right, we are going to look at our polygon angle sum theorem. Polygon angle sum theorem. Polygon is a multi-sided shape, and we're going to be looking at the angles. We're going to be looking at interior angles and exterior angles. So our interior angles are our inside angles, and the sum, the addition of the measures of the interior angles of a polygon is, the way that we find it is n minus 2 times 180, where n is the number of sides. So the sum of the measures of the interior angles of any polygon is n minus 2 times 180, where n is our number of sides. So if I want to do a heptagon, first we have to figure out how many sides does a heptagon have. And a heptagon has 7 sides. So if I want to know the interior angles, how much they're going to add up to for a 7-sided shape, I take our formula, n minus 2 times 180. N is going to be equal to 7 because we're talking about our heptagon. So we do 7 minus 2 times 180. 7 minus 2 is 5. 5 times 180 is 900. So our heptagon, our 7-sided shape, the inside angles are all going to add up to 900 degrees. Depending on your shape, that changes. So if you did a 4-sided figure, it'd be 4 minus 2, which is 180, or 4 minus 2 times 180. 4 minus 2 is 2. 2 times 180 is 360. All 4-sided shapes, the interior angles are going to add up to 360 degrees. We could do a triangle. Triangle has 3 sides. 3 minus 2 is 1. 1 times 180 is 180. So all triangles, the interior angles are going to add up to 180 degrees. We have 3 different types of polygons that we're going to talk about. We have an equilateral polygon. We have an equal angular. And a regular polygon. Now an equilateral polygon, equal meaning equal, lateral meaning sides, polygon means all sides are the same, or all sides are congruent. So maybe I have might not look like it. We're going to draw little arrows, or the lines, saying all sides are congruent. Equal angular, so equal angular, angle, equal angles. So all the angles, we'll do this. We'll do one like this. This is an easy one to see. All the angles are, the interior angles are the same. So all angles are congruent. Now a regular polygon means all sides and angles are congruent. So maybe I have something like this. So all sides are congruent and all interior angles are congruent. All sides and angles are congruent. Now let's talk about how to find these measures. So if I want to find those measures of a regular polygon, so let's say it's regular, and I want to find the interior angles. So the measure of each interior angle of a regular polygon is, we do our n minus 2 times 180. So we have to figure out how many angles are in the whole thing, and then we divide them by the number of sides. So let's say we want to know that of a regular hexagon. Well, a hexagon has 6 sides. So to find how much each, this is our hexagon right here, 1, 2, 3, 4, 5, 6. So if this is regular, meaning all of them are the same, all the angles are the same, and I want to find out what that angle would be, I take our 6 sides and we plug it into this formula. 6 minus 2 times 180 divided by 6. 6 times 2 is 4. 4 times 180 divided by 6 is going to be 120 degrees. So each angle here would have to be 120 degrees. I'll put it on a couple of them. All of them would have to be 120 degrees. Another type of problem that you could do is, let's say we have a figure, and you can kind of try to draw it. It doesn't have to be perfect. Maybe it looks something like this. And we're going to label this one T, this one O, D, A, Y. This is our quadrilateral, pentagon today. And this angle is 110 degrees. This is a 90-degree angle. This one's 120. And this is 150 degrees. We want to figure out what that angle is. So the first thing that we have to know is how many degrees does the whole shape add up to? And it has 1, 2, 3, 4, 5. 5 sides. So we're going to use n minus 2 times 180, where n is the number of sides, to figure out how many degrees the sum of those measures will equal. We have 5 sides, so 5 minus 2 times 180. 5 minus 2 is 3 times 180. 3 times 180 is 540 degrees. So all angles are going to add up to 540 degrees. So we take all of our angles that we have here, 110 plus, this one's 90, plus 120, plus 150, plus, we don't know what this one is, so maybe we'll call it y because it's the angle y. And those are all going to add up to 540 degrees. So we'd add up all these, 110 plus 90 plus 120 plus 150. When we do that, we get 470 plus whatever our y is equals 540. Now we're solving for y, so we're going to subtract 470 from both sides. Those cancel out. We get y is equal to 540 minus 470 is going to be 70 degrees. So that angle is 70 degrees right there. Now we're going to talk about exterior angles. Now exterior angles are angles on the outside. So let's say I have a shape. We'll start with this one. We'll start with a triangle. And to find the exterior angles, what I do is I just extend each of the lines. If you extend each of the lines, this is how we get our exterior angles. So there's an exterior angle, there's an exterior, there's an exterior. So we extend all of those lines. We could do any shape. We'll do a pentagon, like a house. And if we extend each of these, now I kind of I like to go in a clockwise or counterclockwise manner as I do this. And I make sure all of my angles or all my sides are extended, and then that creates our exterior angles. Now, the exterior angles are kind of interesting because the sum of the exterior angles of a polygon, so it doesn't matter what shape that you have, what polygon that you have, is it's always 360 degrees. So no matter what shape you have, if I were to add up all of these angles, they'd always be 360 degrees. Now, if we have a regular shape, we can figure out how many degrees that is. So let's say here I have 360 degrees are going to be all of those. If this were regular, we're going to assume that it is. It's not. But if it was regular, we divide it by the number of sides there are. So 360 divided by 5. When we go to do that, we get 72 degrees. So each of these would then be 72 degrees. This one looks more regular because those are all the same angles. So this one, 360 degrees, and I divide it by the number of sides. So 3. So each of these would be 120 degrees. If I wanted to find the measure of a 36 gon, so when we get bigger side or bigger shapes with a lot more sides, we just say it's a 36 gon. Because we do have our triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon. And then kind of after that, then we're just going to start writing the numbers out. So if I want to find the measure of the exterior angles of a 36agon, well, we know all those angles are going to add up to 360 degrees. We divide it by the number of sides, so 36. And so each of those would then be 10 degrees. I have one more type of problem that you're going to look at. And to set it up, we're going to say the sum of the measures of the interior angles is 1080. So the sum of the measure of the interior angles is 1080 degrees. We want to know how many sides this shape is. What is n? So we're kind of going back to our interior angles. Remember, our formula for interior angles is n minus 2 times 180. But this time I'm telling you it equals 1080. So we're solving for n. Because this is multiplying here, we have to undo that multiplying first. So we're going to divide by 180 on both sides. Those cancel out. I get n minus 2 is equal to 1080 divided by 180 is 6. Add 2 to both sides. N is equal to 8. So this is an 8-sided, an octagon. The interior angles are going to be 1080. All right, so that concludes these notes, and then we're going to now look at what our assignment is going to look like for this.